You type a few words, and the rest of the sentence appears before you finish the thought. Your phone unlocks the moment it sees your face. A map predicts traffic before you reach it. A chatbot answers in a tone that feels calm, fluent, strangely familiar. It is easy to feel as if artificial intelligence understands us now. Not just our commands, but our habits, our language, even what we are trying to say. But that feeling is exactly where the real story begins. Because AI does not understand in the way we do. It has no awareness, no beliefs, no inner world behind the screen. And yet, it can still recognize, predict, imitate, and respond with remarkable accuracy. So what is it actually doing? To answer that, we have to step back to how older computers worked. Let's get into it right here on Secrets of Simple Things. When rules were not enough. Before modern AI, computers had to be told almost everything in advance. Humans wrote the rules, and the machine followed them step by step. If you wanted a computer to recognize a cat, you had to describe what a cat should look like. Pointed ears, whiskers, fur. That seems sensible. But the real world does not stay neat for long. What happens when the cat has folded ears? What if the photo is blurry, the lighting is poor, or the animal turns away? The moment reality begins producing exceptions, rigid rules begin to fail. That was the deeper problem. The world contains too much variation to be captured by a giant list of instructions. You cannot write a separate rule for every unusual case. That is where traditional programming reached its limit. The moment we stopped teaching by command. The breakthrough came when people stopped trying to explain things to machines one rule at a time. Instead of handing the computer a complete instruction book, they gave it examples. Thousands of cats, thousands of things that were not cats. From that growing pile of labeled data, the machine began to notice patterns for itself. In that sense, machine learning works less like a rule book and more like early childhood. You do not teach a child the formal definition of a cat. You point, repeat, correct, and let recognition slowly take shape. Over time, the child notices what tends to appear together, not because the concept was explained perfectly, but because the pattern kept returning. That is what changed everything. AI did not suddenly become intelligent in the human sense. It became useful because it could absorb more examples than any person could sort by hand, then build its own pattern system from that data. But seeing examples is only the beginning. The real question is how the machine turns those examples into something it can use. How a neural network sees without seeing. To do that, modern AI often uses something called a neural network. The name can make it sound as if a brain has been built out of code, but that picture is misleading. A neural network is better imagined as a layered system for sorting and combining signals. It is inspired loosely by the brain, but it is not a brain. It processes patterns. Imagine showing the system a handwritten number 9. The first layer does not see a number at all. It only notices basic features. A dark pixel here, a curve there, a straight line somewhere else. The next layer begins combining those fragments. Now the system can detect a loop at the top and a vertical stroke below it. A deeper layer puts those pieces together and reaches a stronger conclusion. This arrangement is likely a 9. That is the basic logic of deep learning. The early layers notice simple details. The deeper layers assemble those details into larger structures. And with enough layers, the system can identify patterns far more complex than any single line or curve. But none of those layers would matter if the system had no way to learn from its mistakes. Why mistakes are the real teacher. At the beginning, an AI system is usually terrible at its job. Show it a cat, and the answer may be wildly wrong. It has not learned the useful patterns yet, so its first guesses are little more than noise. What changes that is feedback. Each time the system makes a prediction, that prediction is compared with the correct answer. If it gets the result wrong, the error is sent back through the network as a signal to adjust. Inside the model are countless tiny settings, often called weights or parameters. Imagine them as an enormous board of microscopic knobs. Every mistake turns some of those knobs by a tiny amount. After millions of examples, those small corrections begin to accumulate. The system becomes less random and more reliable. Eventually, it starts reacting to certain visual patterns in a consistent way. That does not mean it understands what a cat is. It means its settings have been shaped to respond correctly when the usual pattern of a cat appears. Recognition, in other words, comes from repeated correction. But recognition is only part of the story. When prediction starts to sound like thought. Some AI systems do not just recognize things, they generate things. They write, answer, summarize, translate, and sometimes sound uncannily human while doing it. This is generative AI, and its game is different. Instead of deciding what an image is, a language model predicts what should come next in a sequence of words. Think about the phrase, "The quick brown fox jumps over the..." Most people can guess the next word quickly, not because they discovered a truth, but because they have seen that pattern before. A language model works in much the same way, only at a vastly larger scale. It absorbs enormous amounts of human writing and learns which words, phrases, and structures tend to appear together. Then, when you begin a sentence, it calculates which continuation is most likely to fit the context. That is why the output can sound smooth and natural. But fluency creates a dangerous illusion. The model is not necessarily retrieving truth. It is producing language that seems probable and human-like based on patterns it learned from us. In that sense, generative AI is not a mind speaking. It is human language reflected back through a machine. And that is exactly why AI can sound intelligent while still lacking something essential. The illusion at the center of AI. This is the distinction that matters most. AI can imitate many outward signs of intelligence, but imitation is not the same thing as understanding. A human being does not only recognize the word cat. A human being carries memory, feeling, context, and lived experience behind that word. AI has none of that. It has no consciousness, no intentions, no private mental picture behind its answers. It does not know what a cat is in any inner sense. It only knows which patterns usually appear beside that label. That difference is easy to miss because humans respond strongly to fluent language and behavior that appears purposeful. When something answers smoothly, predicts accurately, and responds in the right tone, we instinctively begin to treat it as if there must be a mind behind the performance. Much of that feeling comes from pattern recognition working extremely well. What looks mysterious from the outside is, underneath, a cold and structured system of probabilities, adjustments, and statistical relationships. Once you see that distinction, the story of AI begins to look less like science fiction and more like a long technical history finally reaching the right conditions. The long road to everyday AI. The idea of machine intelligence is old. For decades, researchers asked whether a machine could perform tasks that seemed to require human intelligence. Early systems were ambitious but limited. They relied heavily on handwritten rules and often failed the moment the world became messy. Expectations rose faster than the technology could deliver, and at several points excitement collapsed into disappointment. This is why AI history includes periods sometimes described as AI winters, when funding slowed and confidence faded. What changed was not the dream itself, but the environment around it. As the internet expanded, enormous amounts of data became available. Computing power also grew dramatically. That combination changed the scale of what machines could learn from and process. Models could become larger, deeper, and more capable. Tasks that once sounded impossible, like real-time translation, image recognition, or natural-sounding text generation, moved into ordinary life. So AI is not one invention that suddenly appeared. It is a collection of technologies that matured slowly, then accelerated when data and computing power finally caught up with the idea. The quiet machinery of everyday life. That is why AI now feels both ordinary and strange. Not because one giant intelligence is running the world, but because many smaller systems are quietly handling narrow tasks all around you. AI helps unlock your phone by matching your face to a learned pattern. It recommends the next show by comparing your habits with those of millions of other viewers. It predicts traffic by analyzing movement, timing, and route history faster than any person could. It sits inside tools that recognize speech, sort images, translate text, filter spam, detect objects, and generate language. Most of the time, we barely notice it. Each system is doing something specific and easy to take for granted. We imagine one mysterious force when the reality is a network of specialized tools working quietly in the background. Once AI becomes ordinary, the real question is no longer whether it feels impressive. What AI really is, beneath the illusion. So what is artificial intelligence in the end? It is not a machine waking up inside the screen. It is not a hidden mind slowly becoming human. It is a human-built system that learns from data, detects patterns, adjusts through error, and turns all of that into prediction. That is what makes AI powerful. It can recognize, recommend, generate, translate, and respond at astonishing speed and scale. But none of that means it possesses inner understanding. There is no awareness behind the performance, only structure refined through repetition. And that is the part that matters most. What makes AI feel so extraordinary is not that a machine soul has appeared, but that human beings found a way to let a simple logic learn at massive scale until it began to resemble something almost alive. If this video changed the way you think about artificial intelligence, subscribe to Secrets of Simple Things for more stories hidden inside the things we use every day. And if there is another ordinary technology you have always understood on the surface but never really questioned, leave it in the comments below. It might become the next story we uncover together.